one of the wettest places on Earth, into a patchwork of arid savanna. Summer 2005, the Amazon River. Extreme heat teems with the driest conditions anyone can remember. It's the perfect drought. Few can recall a time on the mightiest river in the world when its tributaries ran dry, not low, dirt dry.
In 2005, we saw a situation in the Amazon which was just incredible. It was completely off the scale. The Brazilian army actually had to fly by helicopter huge quantities of water up the dried up Amazon tributaries in order to stop people dying of thirst in villages which are normally on the edge of this enormous river.
First drought, then fire. In the aftermath of summer 2005, over 2,500 square kilometers of the rainforest burn. Trees help generate 50% of the water for rainfall in the Amazon. As more forest is lost, the very source of the Amazon's rainfall diminishes.
For every tree that we lose, we're making one more incremental step towards a scenario of drought and fire in the region.
Ecologist Daniel Nepstad has been studying the Amazon for over 25 years and sees global warming and deforestation pushing the region toward a tipping point.
We think that maybe as early as 20 years from now, we're going to see what we call positive feedbacks kick in, these vicious cycles of drought leading to fire, leading to more drought. And that's much sooner, of course, than the climate models are giving us.
In the extreme conditions of a world warmer by 3 degrees, losing much of the Amazon could cause the re-release of hundreds of millions of tons of stored carbon, perhaps intensifying global warming another degree.
If we get to 30 years from now and the Amazon is brushland, I think I would look back and say we had a chance to save one of the world's great treasures.
A world warmer by 3 degrees could finally tip the balance on runaway global warming. Nothing in our past prepares us for these extreme conditions. A time when the rare 100-year storm becomes a common event. In a world warmer by 3 degrees, climate change could be manifest in the most violent weather humans have ever experienced.
People don't yet realize the changes that we're talking about could really lead to a different planet.
As the oceans get hotter and hotter, a new global climate pattern emerges, mirroring the violent weather anomaly we call El Nino. But in a 3-degree world, those extreme conditions could become the status quo. There's evidence for this in the past.
Back in the Pliocene, for example, when it was about 3 degrees warmer than it is now, the whole ocean circulation pattern in the Pacific was different, and there was essentially a permanent El Nino.
Normally, the trade winds drive warm ocean currents toward the western Pacific, leaving cold, nutrient-rich waters along the coast of South America. El Nino turns that system upside down. The first signs are wild fluctuations in air pressure. The trade winds weaken and completely change direction. Warm water spreads east across the Pacific. Torrential rains and flooding strike coastal South America. Indonesian rainforests and Australian farmland experience extreme drought conditions. And many climate models include another troubling forecast. Continued warming could turbocharge a new generation of superstorms.
In a world which is 3 degrees warmer, there's going to be a lot more energy in the world's oceans to drive hurricanes. And hurricanes derive their rocket fuel from the warming of the ocean.
Scientists are still investigating a connection between global warming and hurricane strength. Lately, they have seen more violent storms. Hurricanes are rated on a scale of 1 to 5. One study concludes in the last 30 years, there have been twice as many severe storms. The summer of 2005 would bring dramatic new evidence. In late August, a Hurricane Hunter aircraft is dispatched over the Gulf of Mexico. A colossal storm is building and tracking straight for the city of New Orleans. Anyone left there has only one word in mind: Katrina. By Sunday, August 28th, Katrina's winds reached 280 kilometers per hour. Thermal imagery along the storm track reveals Katrina's clout. Orange and red indicate the sea temperature has risen to 82 degrees Fahrenheit, a full degree higher than normal. Dropping pressure within the eye wall is the 4th lowest ever recorded for an Atlantic storm. It revs Katrina even more.